Welcome to General Chemistry GES 151 practical session. Today, dear students, today we are going to start experiment number 4, which is about chemical reaction. The title of the experiment is Chemical Reactions. In this experiment, uh, we will discuss, as you see in your screen, we will discuss the objectives of this experiment. And after objectives, we will talk about the theoretical background of the chemical reactions in which we will study the common reactions and then how the evidences of these chemical reaction we can find. And then at the end, we will talk about apparatus. And after this session will be ended, this video will be ended, and you will find the demonstration from your teachers from the lab. Objectives: to observe some typical chemical reactions. This is the first objective. Means we have a lot of chemical reaction in chemistry, maybe thousands and you can say tens of thousands of chemical reaction. But we will talk about here only common typical reaction in which we study all these reactions. We can see them in our daily life, or we already study these kind of chemical reaction from the high school level as well. So to the second objective is to classify chemical reaction into different types. Now, if we have a chemical reaction, this chemical reaction belongs to which class? So we have different classes of chemical reaction. So each chemical reaction we will give it a different class. So some of the chemical reaction may be of the same class, some of them may be of different classes. The third objective is to identify some of the products as evidence of chemical reaction. This is a very important one because when the chemical reaction is happening, so we don't know exactly sometimes so what is going to happen inside the chemical reaction. In these type of chemical reaction we are doing, so we will definitely observe the evidence, means we will observe the proof of the chemical reaction. And these proof actually it gives us indications that the chemical reaction is being in process. So we will talk about it in details, what are the evidences of this chemical reaction. The last objective is to summarize the chemical changes in terms of balancing chemical equation. This is the last one. So in this part, whenever we do some chemical reaction, of course we will do the chemical reaction in the lab, but when we try to write it or we want to discuss it, we will write a chemical equation. The chemical equation is we will talk about it. It is the formulas of the compound. We don't need to go to the lab, but we need only the formulas of the compounds or elements, and then we will have a proper how to express a chemical reaction in the form of chemical equation. So these are called chemical equation. Of course, we will balance it later on. Now we come to the theory part. The theory part, first of all, we should know what is chemical reactions. So if you look at the definition of the chemical reaction, it is a chemical change in which one or more substances are destroyed and one or more new substances are created. It means a chemical change or chemical reaction actually it happens when you have something before, they will add together, they will mix together, and then they will make new substances. Now the new substances may have different nature, they have different properties than the previous substance. So for example, we have given example of the formation of water, in which you can see here we have before and after. Before we have H2 gas, which is hydrogen gas, and then we have O2 gas, which is oxygen gas. So when we burn hydrogen gas in the presence of oxygen, hydrogen will react with oxygen. If you can see here in the diagram, the first diagram, the left one H2 is on the top, the second is on the bottom, and in the middle there's O2. So now what they will do, they will mix with each other. We usually in the chemical term we call them react with each other. they will react with each other, and then they will go to the product side, the right side, which is H2O, means two hydrogen with one oxygen is being attached. If you look at the arrangement here, the arrangement on the left side is completely different from the arrangement on the right side. In arrangement on the left side, hydrogen are two together, and oxygen are two together. But if you look at the right side, each two hydrogen, they are not even together. Now, in between two hydrogen, there is oxygen, which is the water formula. So that's why we cannot write H2O2 on the right side. We will write H2O. But how many molecules of H2O we have? Two. So we can write here two hydrogen molecule means two H2, one oxygen molecule O2, and then we go to the right side, we have two H2O. So this is what happens actually in the chemical reaction. If you look at the left side, they mix with each other. H2 is being destroyed. Now in the right side, there is no H2. O2 is on the left side, but on the right side, there is no O2. This is being destroyed. But what happened then? They destroyed, but they made new things. Means water is a new substance in which hydrogen is there and oxygen is there, but the property means the properties of the water is completely different from the properties of oxygen and hydrogen. Means oxygen we need to breathe, means we need for breathing, for even for our life, for all animals life, oxygen is important, means we cannot survive without oxygen. But look at the water, oxygen is there, but we cannot breathe water. We cannot take it to the lungs because we need for our food, for our stomach actually. We need to drink water, not to inhale water. So, and then hydrogen gas, it's very explosive gas. But in the water, it's, water, there's no properties of hydrogen. So that's why we call it, this is a chemical reaction in which substances, they react with each other and make new substances. Parts of chemical reaction is we will show it to you. There are two parts of the chemical reaction. One is on the left side, one is on the right side. The left side part is called reactants. What we call it? Reactants. And then the right side part is called products. It means reactants are those substances, elements or compounds, they add together to mix. They react with each other. They mix with each other. Products, after mixing, they will rearrange themselves and then we will get products. Reactants, if you look at the definition of reactants, substances that are destroyed by the chemical change, bonds break. We have, suppose, H2O2 in the previous slide, we gave example of H2O2. H2, there is a bond between one hydrogen and another hydrogen. When they are reacting with O2, the bonds between H and H, they will be broken, it will be broken, and then the bond between O2, which is O double bond O, it will also be broken. So the bonds between the atoms of the compound will be broken and new bonds will be formed. Okay, so product substances created by the chemical chain, new bonds form, as I told you before. So in products are new always, they are new substances. Okay, so the arrow is red is yields. Yields are produced. Means the arrow means, now if you look at the part here on the top, reactants and then arrow products. It means reactants produces products or reactants yields into products. So these are two parts of the chemical reaction. All chemical reaction, they have two parts, reactant side and product side. Reactants may be 1, maybe 2, maybe more than 2, 3, 5, 10, 12. Products may be 1, maybe 2, 3, 4, 5, means many, more than this. So we don't care about these things, but we should know that the arrow means it is in the middle. On the left side of the arrow, we have reactants. On the right side of the arrow, we have products. Now, other symbols in chemical reactions. Sometime, we will see here, means after the slide. So we use the physical states. Suppose we have O2, which is oxygen. Oxygen is a gas. So definitely we will use G in a parenthesis. When we write O2 and then we will write G in the parenthesis, G means gas. If anything is solid, suppose we talk about sugar. Sugar, we know it is crystalline solid. It is solid. Whenever we react sugar with something, and we will write the formula of the sugar, like C12H22 O11. So what we are going to do, uh, we have to write S in the parentheses after the formula of the compound. And then if something is liquid, like water is liquid, we will write liquid. G is for gas. AQ is very common in our reactions. Usually, most of the reaction we do in our lab, we write AQ. AQ means aqueous. Aqueous means, what do you mean by aqueous? Aqueous means anything you dissolved inside the water. Usually the solid substances, they don't react with each other. We have to make, and we have to prepare them for the reaction. For this purpose, we dissolve them in water and then mix them together. So when we dissolve them in water and then mix them, then they will react. That's why most of the reaction you will see AQ. AQ means aqueous. Suppose we have sugar, we can put inside the water. Suppose we have 5 grams of sugar, we 1 spoon of sugar, we add into the water, we mix it, it dissolves. Now this is called sugar solution. When we write the formula, we will write the formula of the sugar, and then in the parentheses we will write AQ means aqueous. Okay, so and then plus signs means, plus sign separates two or more reactants or products. If suppose we have two reactants different, suppose we have a hydrogen gas and oxygen gas, they are reacting with each other, so we will write H2G for means hydrogen is gas, plus O2G means oxygen is gas as well. So means hydrogen plus oxygen means there are two reactants. That's why we write only one plus. If we have suppose three reactants, we have hydrogen, oxygen, and chlorine. Suppose they are all gases, so we write H2G plus O2G. G is the physical state gas, plus Cl2G. It means chlorine gas. We will add, we use plus 2 times because there are three reactants. If there are four, we can write plus 4 times. Same is for the products. Sometimes we get one product, sometimes we get more than one product. Okay, so we will write plus and plus and plus. Between each substance, between the formula of each substance, we will write plus, and then we will write the other one. Okay, so as I mentioned before this, the arrow means produces sign, separates the reactants from product. So arrow is in the middle. On the left side, reactants, on the right side, products. Now we come to the evidence of chemical reaction, because these reactions are very common, so we can see the evidence. Evidence means proof. What are the proof of these reactions? So first of all, we will list it and then we will discuss it. Evolution of light or heat. Some of the reaction, when we are doing some reaction, we see some light coming out of them, or sometimes they are heated up, means they produce a lot of heat. So we can determine by it. Even by thermometer light, we can see it. We can see by our eyes. Heat we cannot see with our eyes usually, but we can find with the, if it is too much heat, they produce fires, of course we can see it. But usually we can use the thermometer to show the temperature is going up or going down. It means there is something happening inside in the process. Now the change of color, some of the, not all of them. So these are for specific. We cannot say that all reactants they evolve heat or light. No, it's not possible. Some of them they evolve light or heat. And then change of color. Some of the reactants and products, reactants, when they mix with each other, they make products. We can see a color change. And then evolution of gas. Some of the reactants, when they mix together to make products, one of the products may be gas. Suppose you have two liquids, reactants, you mix them together, and then you get a product which is a gas like H2. So definitely gas will come out of the liquid surface and you will see bubble formation. We can say evolution of gas. Okay. Next is precipitation. Precipitation means if you have two liquids, you mix them together and one of the product may be solid. When one of the product may be solid, it does not dissolve, so it will settle down. You will see it is the transparent solution. They will become turbid, means it will become opaque. You cannot see across them. Okay, this again we will talk about it in detail. Heat released or absorbed is I mentioned in the first evidence, evolution of light or heat, and then heat released or absorbed. Some of the reactions when you reactant in the product go to the product side, they absorb heat. If they absorb heat, the temperature is going down. Some of them they evolve heat, means when you react them, the product, the product is being made, so the temperature will rise, so you will see the rise in temperature as well. So change in pH, the last one, conductivity or voltage. Here we will talk about only the voltage, not conductivity or pH, because some of the reaction, actually they are redox reaction, the electrons are moving from one reactant to another one. So that's why whenever the electrons are moving, we have a multimeter we'll put in the middle, so that when the electron moves, we can see the voltage in our multimeter. So all these lists, now we will go into the details of these one. Evolution of light or heat. This is first example. You will see your teacher will demonstrate it. So we have a magnesium metal. It is a metal solid. We have a ribbon actually. So we will take a small piece of it and then we will burn. Whenever we are burning, actually it means the reaction with oxygen. When we burn something, it means oxygen in the atmosphere, they will react with each other. So magnesium, when you burn magnesium, there's only one product, which is MgO2, Mg plus solid. Mg is solid, O2 is gas. So you will see 2MgO, which is a solid, but during this product formation, you will see a white light. So it means this is the evolution of light. Okay. And the second example is you have sodium. Sodium is a metal solid, and you put into the water, which is liquid, you will have a sodium hydroxide and H2 gas. H2 gas, it produces a lot of heat, and hydrogen gas, and this hydrogen gas may burn. You can see the fire as well. Heat released or absorbed. Some of the reaction, we call them, they absorb heat. Absorb means they get heat from the environment. Some of the reaction, they evolve heat, means the heat is being released. Evolve heat. Now, how can I know this reaction? It's absorbing heat from the environment, or how can I know that some reaction or one of the reaction it evolves heat? It's very simple. If you have a thermometer, you put the thermometer during the process. If the temperature is rising, suppose you have a 35 degrees Celsius temperature, means the room temperature or the lab temperature are 30 degrees Celsius. If it goes to 60 or 70 degrees Celsius, definitely you know that things are getting heat up. So it means if the temperature is rising, in this reaction, actually we call it, this is exothermic reaction. Heat is being released during the reaction. When the products are being made, heat is being released. It's going out. That's why you can see the rise in temperature from thermometer. So what about the other one? When the heat is being absorbed, it takes heat from outside. Okay, so this is called, how can you know that if temperature is 30 degrees Celsius and then you are mixing two reactants, they are making product, and the temperature falls down, suppose it comes to 10 degrees Celsius, maybe 5 degrees Celsius, it means obviously you know that it is, heat is being absorbed. So for this we use terminology, we use two terminology, endothermic and exothermic. If you can see the diagram, in endothermic we put an ice. Ice gets heat from outside. Ice gets heat from outside. That's why it's been melted. So this has become cold. It is endothermic reaction. And what about fire? Fire give heat to the environment. It's going out. So this is exothermic process. Now these are actually the processes. What are the reaction? The examples we have. In the first one we have ammonium nitrate, solid. When you mix with liquid water or you want to dissolve it, so it will give you ammonium hydroxide aqueous plus HNO3. But this during this process, so you will see the fall in temperature, means the temperature falls down. It will fall down, and when it will be decreased. So it means this endothermic. What about the other one, like calcium chloride? You dissolve in water, so it will give you calcium hydroxide aqueous plus 2HCl aqueous as well. But this reaction is exothermic because the temperature will rise. In this temperature, it will release heat. So we have two types of reaction, exothermic and endothermic. Endothermic means when the temperature goes down, means from 30 to 10, or maybe from 30 to 15 degrees Celsius, or maybe less. If temperature rises, suppose it goes from 30 to 50 or 60, this is exothermic reaction. The next stage, gas is evolved or released. Sometimes some of the reaction they produces gases. Suppose we have two liquids or solids, you mix them together. So what happen in the end? So they produce gas. If you have a gas in a liquid, definitely the gas is very lighter. It will come to the surface. When it's coming to the surface, you will see the bubble formation. Bubbles are coming out and they will pop out when they come to the surface. So you have example, suppose you have two example, magnesium, which is solid. You put into the HCl, which is a liquid here. You can see the magnesium solid in HCl liquid. You will see some bubble formation. Look at this in the right diagram, in the right side. You have two pictures in the right side diagram. The one which produces bubbles, this is actually H2 gas. So this is a kind of evidence for us that magnesium is reacting with HCl and we produce H2 gas. Okay. The other one is calcium. If you have a calcium metal, you add into the water, you have calcium hydroxide plus H2 gas. Still you produce, you can see the smoke coming out. Actually, this is some of the, the vapors as well as hydrogen gas. Color change. Some of the reactions, reactants, when you mix them together, they go into the product, they change their color. So the best example we will do in our lab as well, this is about acid-base reaction. We have an acid, sodium hydroxide aqueous, which is a base, plus HCl aqueous, which is an acid, strong acid. When you mix them together or you add them together or react them together, it produces sodium chloride, which is a salt, and water, which is a water is a liquid, not a gas. Okay, so in this case, the pink color is due to indicator. You will see acid when you have an indicator. You put one drop here. Suppose you will not see any color, and then what you are going to do, you will add base to it. This one, you will add base to it until the color change into pink color. When you see the pink color, it means the solution is basic. When you see the transparent color, it means the solution is acidic. It means here HCl on the left side is HCl, on the right side it is sodium hydroxide. So in sodium hydroxide, the indicator gives you a pink color. What is the name of indicator? For this indicator is called phenolphthalein. It is phenolphthalein. Formation of precipitate. Some of the reaction, they don't produce gas, they don't produce heat, but they produce precipitate. You can see in these three different diagrams. In the first one on the left side, you have a white precipitate. It's settled down. You have water on the top, and the down there is some precipitate. So the second one, you mix two solutions, but you can see red precipitate is being made. It's being produced. Precipitate, and then the right side, the rightmost picture, you can see that you adding to solution, but you will see yellow precipitate. It depends upon the substance you take. Sometime you will have white precipitate, sometime you have red precipitate, or sometime you have yellow precipitate, or whatever it is. So it depends upon the substance. What is precipitate? Precipitate is actually you are mixing two liquids, transparent liquids there, but they are making solid. One of the product must be solid. That's why, and this solid must not dissolve in the solution. Suppose if I give you example, I'm reacting two substances and I'm getting sugar. It is in the water, but sugar is still soluble in the water. So I will not get any precipitate because sugar is my product, but sugar is soluble means it can be dissolved immediately. So I will not get any solid. You must get a product which is insoluble in the water, insoluble in the solution. That's why you will get a precipitate. Now, what is the color of the product? If it is white, you will get white precipitate. If it is red, you will get red precipitate. If you have the color is yellow, you will get yellow precipitate. Change in voltage, you can see here in these two diagrams. Moving of electrons in external circuit gives voltage. Of course, you will have a multimeter, and then when electrons are moving from one side to another side, you will see the voltage will be maybe 1 volt or maybe less or more than 1 volt. So it depends upon how many electrons are being released or absorbed during the reaction. So this is change in voltage. Some reaction not all reaction. If suppose we go for the precipitation, we will not see any change in the voltage because there is no transfer of electron from one to another side. When there is a transfer of electron from one side to another side, means from one reaction to another one to make products. So definitely there is a, we will find it, what is the evidence? The evidence should be the voltage. And then we can use the multimeter or any voltmeter to for the deflection or for the confirmation. Have combustion reaction, decomposition reaction, but we will not show you in the lab. This is only for the theory. But for the combination, replacement reaction. And replacement reaction, what happens? Copper element replaces silver element in a compound. If you look at this, the general formula A, which is the red one, plus means A is a different reactant, and then By is a different reactant. We have two reactants on the left side, A separate and By is another reactant. So what happens actually, if you look at this one, this diagram, A goes to replace B. A takes the position of B. Where is B? B is going out. So next product will be AY plus B. AY means what happened in AY? AY means where is B? If you look at the reactant side, we have Y is with B, but on the product side, Y is with A. Where is B? B is going out. So this is called replacement rate. We call it usually a single replacement because only B has been replaced by A. B is going out. The best example is I think the teacher will show you in the lab as well. We have a copper which is solid here if you can see in the diagram as well, the copper wire. And then we put 2 Ag 2 is number of moles. Ag 3 is silver nitrate solution. This is aqueous. It is colorless. Copper is, the copper has its own specific color. And Ag 3 is a colorless solution. And then copper nitrate, when you react with them, they will become copper nitrate. Copper nitrate is a salt of copper. It has a blue color. You can see a blue color on the right side. You can see a little bluish color in the diagram. And then plus 2 Ag. What is this solid? On the right side of the diagram, you can see two diagrams. One is on the left, one is on the right. So the right side, you will see some particles, grayish particles. This is actually silver. So it means silver will going out into the solution or out of the, it will be precipitated out. And then copper react with silver nitrate to produce copper nitrate is the blue solution plus 2 Ag. 2 Ag means Ag is silver. So the silvers, you can see the particles are of silver particles. This is the evidence. So what is the evidence here? The evidence is we can see, the students, if they want to write, what is the evidence in this reaction? You can see the change. Evidence means you observe it. I can see grayish particles in the blue color. The blue color, it's because of the copper nitrate. In the grayish particles, you can see when you shake it, the particle will settle down. So this is actually silver. So we can see the silver particles, the gray silver particle. This is the evidence of the chemical reaction. Now we have another single replacement reaction. Suppose we have magnesium here and 2HCl. You will see magnesium chloride plus H2 gas. Magnesium is a metal. 2HCl. HCl is a gas. Sorry, it is a acid, which is aqueous solution. And then you will see magnesium chloride aqueous plus H2 gas. So look at this. We are not looking at the evidence. We are looking at the magnesium hydrogen. Hydrogen has been replaced. Magnesium takes the position of hydrogen here. Means here, if you look at the reactant side, chlorine green is with hydrogen, which is black. But if you look at the product side, chlorine green, where is hydrogen black? Hydrogen is out. Who comes in? Magnesium. So this is also a single replacement reaction. We will see bubble here. Now in the replacement reaction, we have a double replacement reaction as well. Suppose, look at this. If you look at this reactants and product, the animation here or the explanation here. A, the green one. B is, it's a kind of bluish one. C is a kind of, it's an orange one or a yellow one, and D is a purple one or the violet one. So you can see A In A, it is B there with it. And C, D are different reactants. A, B is different reactant, C, D is different reactant. When they're going to product, they exchange their position, exchange their parts. Suppose with A here it is B, but here is D. It means B has been replaced by D. Who replaced B? D. But in this other, we can say in the other words, we can say that what about C and D? Here, if you look at the reactant side, we have C and D. But on the product side, where is D? There's no D, but with C, there is B. It means they swap their changes. Suppose we can say swapping of your positions. Swapping means some students that want to swap their stools, their position, their chairs. So this is a double replacement reaction. The previous two reactions were single replacement reaction, in which only one replacement occurs. Here, not only one, two replacement occurs. B has been replaced by D and D has been replaced by B. The example is barium nitrate, which is aqueous, potassium chromate, which is also aqueous. You can see barium goes to chromate and potassium comes to nitrate. So this you can say it is a double replacement reaction. This is the pink color in this slide. White color, we call it a white precipitate. This is the evidence, white precipitate, and then HNO3 is an acid. Redox reaction. Redox reaction are those reactions in which electrons are transferred between reactants. Suppose one reactant, you have an example here, zinc solid, copper 2 plus aqueous, zinc 2 plus aqueous plus copper solid. What happens actually? Zinc will go to the product side, but zinc plus 2 becomes zinc plus 2. It means 2 electrons have been lost. If you can see loss of 2 electrons, this is called oxidation. Before this redox reaction, we should know what is oxidation and what is reduction. If you look at even the name redox, reduction, oxidation. What is reduction? Reduction means gain of electron. If an atom or group of atom or ion or whatever it is, it gains the electron, one or more than one, during the reaction, we call it, this is a reduction process. It's been reduced. And then oxidation, what is oxidation? Loss of electrons by atoms or ion. If any atom or group of atom or molecule or whatever it is, it loses electron, one or more, we call it, this is oxidized or oxidation process. Okay, if you look at this equation here down, zinc, the yellow one, goes to the product with zinc plus 2. Here it is nothing. Here it is 2 plus. It means it loses 2 electron, loss of 2 electron, it is oxidation. Whatever copper 2 plus, copper is copper 2 plus in the reactant side. But if it goes to the product side, it will become copper nothing. Nothing means 0, it is 0. So it gained 2 electron. When some of the atom or ion or whatever it is, it gains electron, we call it this reduce or reduction. So gain of 2 electrons, reduction, loss of 2 electron, it is oxidation. Now redox reaction, if this is the demonstration, you have the complete set here. You will see also in the demonstration video as well. This is the Voltaic cell, we call Voltaic cell flow of electrons from zinc to copper. So we have a complete assembly. On the left side, if you see, this is zinc sulfate down. You look at the beaker, the left side beaker, we have zinc sulfate solution, which is, colorless. And then there's something, the metal inside, we call zinc electrode. This is zinc piece, a zinc metal. And then what happened actually, we dipped zinc electrode or zinc piece into the zinc sulfate solution. Now it has been connected to the wire and then go through the multimeter and then go to the other side and then come back to copper, the red side, which is copper side. What is this one? In the copper beaker, this is a blue solution, we call it copper sulfate solution. Copper sulfate solution is usually blue. And whatever copper, this one, the piece of metal which is being attached to this wire, it is copper electrode. Okay, whatever in the middle is multimeter. So what happens when you connect this whole, this complete, when you remove the wires, it will not do anything. There's no reaction here. But and then there's one more thing here. This is called salt bridge. Look at this. This is a hollow tube. There's some solution here. So they will they will not let you stop your reaction. It will continue reaction. This is called salt bridge. Okay, so here now come again to the left side beaker. We have transparent solution. We have zinc electrode. Zinc will go into the solution and then it will lose 2 electrons. 2 electron loss. These 2 electrons will go into the black cable, go into the multimeter, and then come out to the red cable and then go to the copper side. And copper side, actually we have a copper solution which is blue one. It takes 2 electron, and then this copper, when copper takes 2 electron, it will stick to the copper electrode. So what happens actually in the whole process, zinc loses 2 electron, it goes into the external circuit, comes to the copper. Again, zinc loses 2 electron, goes into the external circuit, comes to the copper side. So 2 electrons are always moving from single zinc to the copper. So that's why you will see some voltage. When electrons are moving in, it means there is a current or voltage. So you can see the voltage by means of a multimeter. So what is your evidence? The evidence is the multimeter voltage. Whatever you see during the demonstration, you will write the voltage there. Now we come to the apparatus of this experiment. We have to use many apparatus in this one. If you can see, we start from the test tubes. You can see 5 test tubes here, and then we go for the test tube brake. We have 2 types of test tube brakes. One is the wooden one and the steel one, or like this, the blue one. So both of them, they are test tube brakes, because we have to put the test tube inside the test tube brake. And then the down one, it is test tube holder, which is 2. One is of this, the steel, one is of wood. So we can use both of them. Sometime we will use one, sometime we will use another one. We call test tube holder because we have to hold our test tube with the test tube holder. Go to the left side now. Dropping pipettes. You can see we have dropping pipettes. Usually these dropping pipettes, if we need drops of something, of liquid especially, so we use the dropper or dropping pipette. Sometimes we call disposable dropper. Sometimes we call it dropping pipette. It's both of names are correct. So we squeeze it, means there is air inside. We press it, squeeze the air outside, and then we dip into the solution, leave it. When we leave it, it will take air back, and then with the air, it will take the solution as well. So then we can squeeze again. Accordingly, we can, deliver the drops. Go for the left side. We have a Bunsen burner. Bunsen burner we use for the fire, and then we have to light it by the help of lighter, gas lighter. You can already know it already. So this Bunsen burner has a gas supply, so we can use it for the burning of something or heating of something. And then go for the extreme left side. We have a measuring cylinder. Usually when we take larger volume like 100 ml, 50 ml like this, so we use measuring cylinders. And then the top one is crucible tongs. Crucible tongs means if we want to heat something, so we need crucible tongue. Or something is very hot, something like this, we cannot take by our hand, so we use a crucible tongue. Because in this experiment we will burn magnesium, so we cannot burn in our hands, so we need crucible tongs here. And then the last one is Voltaic Cell. Voltaic Cell, you can see here, there's a zinc metal, copper metal, there's a salt bridge here, so semi-permeable membrane, something like this. So this whole assembly is of the Voltaic Cell. Thank you very much for watching the video. Now you can watch the demonstration video by your teacher. Thank you.
Bismillahirrahmanirrahim. Assalamu alaikum, students. This practical session is about experiment number 3 regarding the type of chemical reactions. And as you have understood in the theoretical class, that the chemical reactions can be classified into different types based on the rearrangement of reactant to give a product. So what kind of a product we're going to get, it will actually plays roles here in the classification of chemical reaction. This is one objective. The second objective in this experiment is to be able to identify some of the evidence of chemical reaction. So you will see which type of evidence is associated with each of the chemical reaction. And the third one is to be able to write down the chemical equation and balance the chemical equation. So we will start first with the combination reaction, but we need to look into our safety concern. As you know, I'm wearing gloves and lab coat and also safety shoes. And the chemicals that we are going to use today, we have the magnesium ribbon, as you can see here, and we have also a copper ribbon here, right? And chemicals, silver nitrate is there, hydrochloric acid, sodium hydroxide, nitric acid, and the indicator. And regarding the glasswares, mostly we're going to use a test tube, simple one, and the test tube holder. Did this one simply by holding the tube like that, right? And we use the clipper here is to hold the ribbon during the performance of chemical reactions. So we will start first with experiment with the chemical reaction number 1.
To start with the chemical reactions, we are going to observe the combination reaction now here. The combination reaction means to combine 2 or more chemical reactants to produce one product. In order to show this practical experiment, we are going to demonstrate burning of magnesium ribbon in the air with oxygen. So I'm going to burn this magnesium using this crucible tongue. I'm holding it. To start the reaction, of course, heat is the condition needed for this. So I'm going to light the lighter, and you can see what's going to happen. Now what's happening? The oxygen in the air is coming to combine with the magnesium ribbon at this high temperature, and it's going to start the reaction. You can make the clear observation. It's giving you a very bright white light with some smoke, and at the end there will be product, and we can observe the color of the product also. Of course, you see the light was very bright. It's not good for direct eyes for some people. You can avoid. Okay, let me put the product down, and now you can see what happened to the magnesium. Now the product is completely white color, and it's in the form of powder. And in this product, magnesium has combined with oxygen to give you magnesium oxide product. So this is a combination reaction.
So the second chemical reaction that we're going to perform here is called replacement reaction. And this replacement reaction requires one element react with a compound. As you can see here, we have the copper react with silver nitrate, and when the reaction happens, the product is copper replacing the silver ion in this solution, so producing copper 2 nitrate plus element of silver. Watch out for the evidence of chemical reaction here. It will be light blue solution due to the presence of copper ion in the solution, so causing the solution to change into blue. But the second evidence also, you can see precipitation of silver element is like a gray precipitate on the what's left from the copper wire in the solution of silver nitrate. So we'll perform the experiment for you. So we have the copper wire, right? And I'm going to take an amount of silver nitrate. You need to watch for the alignment of these two, so you can easily make the liquid, the chemical to drop in. So here you go, hold nicely, and safely holding the stopper here, holding it, and then nicely just turn it to allow the liquid to come in, to pour an amount of silver nitrate inside here. I think this will be, almost enough for the experiment. So next we're going to drop the copper wire into the silver nitrate in this tube. So after allowing enough time for the reaction to take place, we can see clearly the color change in the solution. This is due to the releasing of copper ion into the solution. This is one type of evidence reactions. The other evidence is the precipitation of silver element. So if I shake it a little bit, you can clearly see the silver there. So here we go, we got the product evidence. You got here silver, and also the copper 2 nitrate is light blue solutions. The second replacement reaction is between magnesium and HCl, hydrochloric acid. So what actually happening here, magnesium replaces the hydrogen, and the hydrogen come out as a gas, and the MgCl become as a solution here. So if you look at this drawing, just to show the hydrogen coming out due to the reaction, due to the replacement of magnesium ribbon here. So I will perform the experiment by taking a test tube, but this time, because this is exothermic reaction, so I have to use the test tube holder, right? And then I will add an amount of HCl to the test tube, an amount, just an amount to satisfy the need of today's experiment. So we will add the magnesium ribbon, as you can see here, right? So drop it in, and you will see a reaction happen immediately. As you can see here, the reaction taking place by evolution of gas, hydrogen is coming out, and because it is hot here, we are using the test tube holder. Now, one of the evidence of today of this type of reaction is the evolution of heat. So although the heat is not much, I can actually hold it myself like that. I can feel the heat is already there. So we have the heat, and we have evolution of gas as evidence of chemical reaction.
The next, we are moving on to the third type of chemical reaction, which is known as acid-base reaction, which is also known as a neutralization reaction, in which we react a base and an acid that will produce salt and water. In this experiment, we are going to use sodium hydroxide as the base, hydrochloric acid as the acid, which will produce sodium chloride, salt, and the water. Of course, you are going to see that this acid-base reaction will not produce clear observation. Therefore, we have to use an indicator that will help us to get the observation. This is Phenolphthalein indicator, and this will give you colorless in acid, and this will be pink in base. We are using two chemicals. One is sodium hydroxide. Of course, I'm going to use the acid, not the hydrochloric acid, but it is nitric acid. Let me show you the reaction now. Okay, here I have the test tube, and in which I'm going to add the nitric acid. You can see it's a colorless solution. Okay, Now, the next step, I will add the phenolphthalein indicator, just 1 drop enough for this reaction. So just 1 drop, I'm adding it. You can see that it does not produce any color. So we can conclude the phenolphthalein indicator is colorless in the acid. Okay, now we will continue with the addition of the base, sodium hydroxide. Now I will add the sodium hydroxide dropwise. You can see here, just I add 1 or 2 drops and see that the solution is still colorless, which means the sodium hydroxide is reacting with the acid in the test tube and still extra acid molecules are present. So there will be a point, enough sodium hydroxide when it are added, they will completely react with the acid. You can see that it appears some pink color, but when you shake it goes. When you add enough sodium hydroxide to react with all the acid molecules, so there is no more acid, it's completely neutralized, and additional drops of sodium hydroxide remaining there to give you the pink color, indicating the end of the reaction. So this way we can study the reaction between an acid and base. Of course, indicator plays a major role in this experiment. The fourth type of chemical reaction that we are going to study is known as precipitation reaction. The precipitation reaction, in which when we mix two aqueous chemicals, like you can see AX aqueous and the BY is aqueous. When we mix aqueous chemical, it will happen a type of, maybe what type of reaction, maybe the replacement or double replacement, whatever it is. One of the product will be a solid. You can see here BX, the product is solid. So for this we are taking that example of the reaction between hydrochloric acid aqueous and silver nitrate aqueous, and when we react them they produce two products. One is nitric acid, which is soluble, so we mark it aqueous, and the other one is silver chloride. Of course this is a solid product. Since the reaction is producing a solid product, this reaction is known as precipitation reaction. And also if you look at carefully, it is also a double replacement, and where hydrogen is replacing the silver and joining with nitrate, and the silver is coming back to join with the chlorine, and that's the second replacement, so silver chloride. So it's a double replacement also. Let me demonstrate the reaction now. Here I have a clean test tube, and this is hydrochloric acid. Let me add the hydrochloric acid, which is a colorless solution. Okay, hope it's enough. Let me now add silver nitrate. You can see the silver nitrate AgNO3 is normally kept in dark bottle because silver nitrate chemical is photosensitive, and so they are normally kept in dark bottle. Let me add just 1 or 2 drops. You can see it's producing a white color, a cloudy precipitate. So since the reaction is producing a precipitate, we call it a precipitation reaction. Even though the solution looks milky, if we leave it for a long time, of course all the white color solid will come to the bottom. It will clearly indicate the formation of solid particles. The last reaction that we are going to observe is redox reaction, and this is only for the demonstration purpose we are performing it. Redox reaction is really a combination of two processes here. You see, red means reduction, the OX means oxidation. So we have a reaction in which both reduction and oxidation takes place. We call it a redox reaction. In order to demonstrate this experiment, we have a setup like this. You can see here, which is normally we call it Voltaic cell. You can see here the word Voltaic cell, in which we have a zinc electrode immersed into zinc sulfate solution, and then a copper electrode is immersed into copper sulfate solution. and when we try to connect them through an external wire, and you will see the flow of electron that goes from zinc to the copper. The reason here, zinc, the reactivity is higher than copper, so the zinc atoms loses electron to the circuit, and those atoms become zinc ions. They come to the solution, and those electrons from the zinc, they move toward the copper electrode. Of course, the copper electrode, in which these copper 2+ ions, they will reach there and they will gain this electron, so they undergo reduction to produce copper solid. It will be deposited here. Of course, in order to observe this reaction, we have to make the connection between these two solutions, so to make the circuit complete. So for that, we have to create a salt bridge here. Of course, you are going to see when I show you the demonstration. And also, we can use a multimeter to show the flow of current as observation. Okay, let me go to the demonstration part. Here we have a small Voltaic cell, in which you can see here we have two electrodes. This one is the zinc electrode, then this one is the copper electrode. We are going to place them in this Voltaic cell. You can see the Voltaic cell is divided, separated internally here, and so to keep the two solution not connected at the beginning. Okay, first I'm going to fill this Voltaic cell container by this copper sulphate solution to one side. You can see that this copper sulphate solution is blue in color because it has copper 2+ ions. Okay, fine. Then other half of the Voltaic cell will be filled with zinc sulphate solution. You can see the zinc sulphate solution is colorless. Okay, now what I'm going to do is, before I immerse these two electrodes into the solution, I'll try to connect these two solutions by a salt bridge, in which just I'm going to use a paper and fold it. You can see I just will place them here, and or we can here. Now I have placed the salt bridge, which means try to connect the two solutions to this paper. It will allow the movement of the ions to complete the circuit. Then I am placing, see, the copper goes to the copper solution and the zinc will go to zinc sulphate solution. So now what's going to happen, the zinc is going to lose electron and become zinc ions. It will go to the solution here. Therefore, the electrons will be left in the zinc electrode. It will be rich of electron. Then what will happen here, the copper electrode, the copper solution, it has copper 2+ ion. It will go to the copper electrode and take the electron to become copper deposited. So therefore this electrode will become positively charged. Okay, but in order to make the observation, we are using a multimeter to prove that we have electron in the zinc and the copper. So if we connect them externally, it will allow the flow of the current, and we should be able to see that one. And here you can see I'm connecting the zinc. Let me switch it on. Okay, it should be DC current. Okay, and if when I connect them, you may observe the flow of current and it will create a voltage. You can see it clearly. When I connect them, it's giving you a voltage. This indicates there is a flow of current from one electrode to another. In this case, you can see it's minus reading. So voltage cannot be minus, which means maybe the way I have connected, is wrong. So if I just exchange this connection, you can see now we get almost similar voltage, but now it will be positive reading. So you have to record this voltage.